Welcome to Aryabhat Center for Theoretical Physics. Today we are going to analyze the spin 1 atoms with the help of stern-Gerlach apparatus. Stern-Gerlach apparatus can produce inhomogeneous magnetic field, and this magnetic field can split a beam of certain spin particles into number of definite spin. So this is the stern-Gerlach apparatus, and it can split atomic beam into 3 beam. And this beam has spin 1 atoms, as is equal to 1 atoms, and we can use filter to block any beam in this apparatus. So this is the atomic beam which has split into 3 beam. We can block the 2 beams so that only 1 beam of definite state will pass. So this is the beam with definite state, or we can say that stern-Gerlach apparatus can produce polarized beam. Which has definite state, or atoms in this beam has definite spin. This is the rough sketch of a beam which has split into 3 different beams using the inhomogeneous magnetic field. This is the beam, atomic beam, which is mixture of indefinite spin particles. After the split, the atoms which has positive spin gone into the upper part, the atoms which has negative spin gone into the lower part, and which has no spin has passed straightly through the apparatus. So this is 0, and this is the beam, and we can use a filter like this one to block any beams in this apparatus. Like this, we have blocked the beam 0 and minus, so that only beam with positive spin or positive angular momentum can come out from this apparatus. As again, we can place second apparatus so that only positive will go inside this apparatus, and output will be same positive beam. This is plus, this is 0, 0, and there is inhomogeneous magnetic field in the z axis, in the z direction. And we can use this symbol, we can use the notation for this apparatus. So this is the apparatus as it can split atoms into 3 different beams, and using the notation we can say that these 3 beams has definite state plus, 0 and minus. Apparatus S. So apparatus S has 3 definite state plus, 0 and minus, and here we have blocked 2 beams. We can say that we have blocked 2 beams, so that only one beam of positive state will come out. This is the symbol of this apparatus which has filter. And again this is the apparatus, second apparatus, which has no filter. So this is the input, and again this is the output. This is the second apparatus. Again, if we apply the filter in the second beam too, then we can use the symbol like this one, 0 plus, 0 minus. Filter is applied on the first apparatus, again filter is applied on the second apparatus as, so that only the atoms with state plus can comes out. Again we can apply the different filter on the second apparatus like this. Here we have applied plus, filter on plus and 0 state, atoms with plus and 0 state. Now here in this apparatus S, we have applied the filter on the beams with 0 and minus state, so that only plus state atoms will come out. And here in the second apparatus we have applied plus and applied the what you call filter on the state with plus and 0. Then we can ask what is the probability of getting the state plus state atoms into the through the second apparatus. The probability will be 0, and here the probability will be 1, because the same filter is applied on 0 and minus state. So we can say that the plus state atoms with plus state to be end up in the atom in plus S state will be 1, and from plus S to minus S will be 0, or again plus minus S to plus S will be 0, or again if we apply the filter on plus and 0, again here plus and 0, so that state with minus beam will come out, then it will be again 1. So there can be 9 such amplitude. There can be 9 such amplitude like this, plus, 0, minus. This is the state of first filter, and getting the beam into the second apparatus, plus S to plus S will be 1, 0 S to plus S will be 0, minus S to plus S will be 0, again this is 1, this is 1. All these things are 0. So this is 0, this is minus 1. So these are the 9 amplitude for getting the atoms into the definite state. Now again what we have done, instead of placing the second apparatus parallel to the first apparatus, we have tilted the second apparatus to the angle alpha. Now the atoms are in the state G, plus, minus, and plus, 0 and minus in the first state, and here the second apparatus has also plus 0 and minus, but in tilted direction. Then we can ask what is the probability of getting atoms in the state S, state plus S into the state plus T into the second apparatus. Then we can say that the probability of getting plus S state into plus T state is same as getting the probability of plus S state into 0 T state and plus S state into minus T state. So now we can get the certain we can get any kind of atoms in the definite state in the second apparatus. Again, if atoms are in the 0 state in the first apparatus, getting the probability will be the same. Getting the probability will be same. There can be 9 such amplitude: plus T, 0, 0s to 0T, 0s minus S to plus T, minus S to 0T, and again minus S to minus T. And the probability will be square of these amplitudes, square, and the probability will be the square of this amplitude, and we can write this as plus T plus S plus T plus S star plus, and probability of all these getting all this state will be 0. So 0T plus S, 0T plus S star plus minus T plus S minus T plus S star is equal to 0. So 1, 2, 3, probability of total probability will be 1. So if atoms are in the plus S state into the first apparatus, the getting the probability into the second apparatus will be the sum of all these probability, and which will be equal to 1. So this is how we can analyze the spin 1 particles with the help of quantum mechanics principle. We can place any number of stern-Gerlach filter in this series like this one. This is apparatus 1, this is apparatus 2, this is apparatus 3. We have blocked the 2 beam in the apparatus S. Again we have blocked the upper and lower beam in apparatus T, and again S dash here again. So this is plus 0 minus, plus minus 0, again plus 0 minus. This is apparatus 1, apparatus 2, apparatus 3, all are in the series. And the symbol for this one is plus 0 minus, S for S apparatus, plus 0 minus for T apparatus, and for S dash plus 0 minus. So these are the symbol for these 2 apparatus. And again we can use different filters. Instead of blocking different beam in different apparatus, we can block the same beam in the all these different apparatus, and probability of getting such beam in the through the third apparatus will be from 0 to S, 0 to 0T, from 0T to plus S. These are the probability of getting from 0S state to 0T state, and from 0T state to plus S state. These are the probability, and these are the amplitude, and the probability will be sum of these amplitude. So it will be square of this amplitude. This is the square of this amplitude, and the ratio of the probability from 0 to 0 as square divided by plus as to 0 t is only depends on the t and s dash. So ratio of getting a probability from 1 to 2 and 2 to 3 only depends on the apparatus t and s dash. This is independent of the state of the first apparatus. So this is how we can analyze spin 1 particles using the quantum mechanics principle.